In this video I'm going to be talking about differentiation, and therefore to be differentiation. Okay, now differentiation is all about determining derivatives. And if I'm having y equals to 2x squared plus 3x cubed plus 4, so out of this, to work out this, I would say that dy dx would be equals to, I would have the power multiplies by the coefficient, which is 2 times 2, then x, then the power subtracts by 1 plus having 3x power 3 minus 1, multiply this by the power plus. Now if you differentiate a constant, you get a 0. Yes, you get a 0. So out of that, dy dx would be equals to, here I would have 4x, and this would be plus 9x squared, and therefore this would be the derivative of y equals to 2x squared plus 3x cubed plus 4. Suppose I'm to have another one that I have, in this case I have y equals to, if I have 7x cubed plus 4 out of x, this would be equals to, I'll have 7 times 3x squared plus, this would be 4x per negative 1 minus 1. Yes, the initial power is negative 1, and then this times negative 1. So out of that, I'll have y equals to, I'll have this would be 21x squared, and then minus, because of this negative, 4x per negative 2. And then if I turn it into the initial form, this would be so this would be dy dx, this would be dy dx, and therefore I would have something that would be in form of dy dx would be equals to, I'd have 21x squared minus 4. Now take this to the denominator to become x squared. So this is how you do differentiation. So if I have another example, I have y equals to 4x cubed minus 1 out of x squared. So this would be dy dx would be equals to, this would be 12x squared minus, so we're having the minus there, so minus, this would be, I'm having, this is x, you're having x here to power negative 2, then after that it would be negative 3 times negative 2, and therefore I'd have 12x squared plus, this would be 2x power negative 3, and therefore this would be 12x squared plus 2 all over x power 3, and then this would be your derivative. So at the same time, let's look at the application of differentiation, and you see what we can do when we have them. So that the first application of differentiation here is that determine the gradient of the line. When you differentiate, let's say, an expression, what you get is a gradient, of which, for example, if I have 3x squared plus 7x minus 4 plus 1 out of x. You say let the whole of this be equals to y, and therefore we say y would be equals to 3x squared plus 7x minus 4 plus 1 out of x. And therefore, to get the gradient of which dy dx would be equals to, this would be 6x plus 7, this is 0 of course, plus, here we're having, so it would be -1 multiplying by x power -2, and therefore we have dy dx equals to, this would be 6x plus 7 minus x power -2, therefore equals, here we have 6x plus 7 is minus 1 out of x squared. Now suppose I'm having a problem of this. I've been told to find the gradient function of 5x minus 3 over root x. So I say let 5x minus 3 over root of x be equals to y, and therefore I come here say that y would be equals to 5x minus 3 over root of x, and therefore if I'm to differentiate this, I would say that dy dx would be equals to 5 minus, this would be 3, yes, remember this x is down, so x to power -1 out of 2 minus 1, and therefore I would have y dx being equals to, I'll have 5 minus, this is the same as having 3x to power -3 out of 2, of which this would be equals to 5 minus, this would be 3 all over x to power 3 out of 2. So this is how you would just like come over this kind of a problem, and this is how you could solve it. And for further problems, now suppose you have a problem of this kind. Find the gradient of 2x squared minus 4x plus 2 at a point 1, 1, of which x is 1 and y is 1. So in this case, don't worry about y, because within our expression we don't have y anywhere where we're going to insert it, and we have to find the gradient. Instead of that, I'm going to come here and say that we have our dy, let's get the gradient function. So whereby let y be equals to 2x squared minus 4x plus 2, of which dy dx in this case would be equals to 4x minus 4. Now dy dx at the point where x equals to 1 would be equals to 4 into 1 minus 4, and therefore this would be equals to 4 minus 4, in this case the gradient would be equals to 0. Now this is how we can solve for this, in case maybe you've been given x value to insert in. So this is the gradient after solving the problem. And if you're having such a problem, find the equation of tangent to a curve x cubed minus 2x minus 3 at that point, which is 1, 1. So here what you do, you're going to follow the simple, just get the gradient in this way. Therefore say let y be equals to x cubed minus 2x 3, and therefore dy dx will be equals to 3x squared minus 2. Yeah, the other one is a 0, and therefore we know that if dy dx at a point where x is equals to 1, this would be equals to, I would have 3 into 1 squared minus 2, and therefore the gradient in this case would be 3 plus 2, which would be equals to 5. And therefore know that gradient let's like using the curve function has been good, and therefore the next thing here is to get the equation of the tangent. So tangent is a line that makes a right angle with the curve. In this case, we shall come here and say that, so if it is perpendicular to the curve, this is due to the curve here. Since the gradient of the curve at any point is the same as that of the tangent, the slope of the tangent, and therefore we shall be taking this as the gradient of the curve. But to get the equation of the curve, we know that we are going to say that y1 minus y2 all over x1 minus x2 be equals to the gradient, which would be 5, and therefore we are going to come here. Now since we don't have it, but we know that the expression takes us to y is equals to mx plus c. We could use that. In this case, we are having some, therefore we are going to have here, we are having y minus 1 all over x minus 1 be equals to 5, and therefore y minus 1 be equals to 5x minus 5, and therefore we would have y equals to 5x minus 5 plus 1, and y would be equals to 5x minus 4, and this would be the equation of the tangent. So this is how it would look like.